Commercial Human Space Systems. So here's the overview. Don't write any of these things down. These are just the things we're going to take a look at. And let's start right off. The introduction. So we've already talked a little bit about the space race and kind of how things began, and now looking at where they are right now. Original manned spacecraft started in early 1960s, and if you remember back, the space race was around 57, kind of when things really kind of started going. The government was the only organization going to space, but that has since changed. Recent government budget changes and technological innovations provided an environment for private industry to enter space. So I hope you're not writing all of these things down. The key here is within the last few years, this has become a reality. The trend is advancing and evolving as a legitimate industry and method of transportation. So private companies now are entering the space frontier, if you will. So we now have a commercial human space flight. This call to action was initiated by Dr. Peter Diamandis through the formation of the XPrize Foundation in 1999. So it was a prize that was worth $10 million, and 20 teams competed to get a person up into weightlessness, into this, and they're looking here up to 100 kilometers. That was the goal for this $10 million prize. In the Mojave Desert in California, there was a successful flight test on June 21st, 2004, but the official record was set, and the X Prize was awarded on October 4th, 2004. So here is a little timeline right now, and everything just was all government based up until this point, up until really around 1999, and that was that kickoff of that prize. So the first commercial manned spaceflight was 2004, and Virgin Galactic, well, SS1 won that prize, and that formed Virgin Galactic. So now looking beyond that, we're getting into where private companies are starting to be hired out by the government to send things up into space. So let's take a look at first suborbital flight. That is achieves flights to altitudes qualifying as space but do not achieve or maintain orbit. Typically these are short duration flights, and they take off and land at the same position. So as the Earth is rotating, they will speed up a little bit and then try to land back in that exact same spot. And they don't get high enough to reach the International Space Station, sadly. Spaceship One was the first spacecraft to successfully achieve suborbital manned spaceflight as a private company. And here is a little picture of their one of their ships here. So the mothership, the White Knight, lifts the spacecraft 50,000 feet, which is above 80% of the atmosphere, and then this little pod will launch off of it so that they don't have to fight through all of that, pushing against all the atmosphere. So it's just kind of like a little escape pod. It's very similar to what Chuck Yeager did when he broke the sound barrier. So then this is launched off, and then out they go for a few minutes of weightlessness for about $200,000. Or maybe more, actually. So here's a little diagram, the first non-government manned spacecraft. A little diagram showing different components. If you want to pause this, check this out, feel free. So looking at the major contributors to some of this commercialized spaceflight, Peter Diamandis, I'm pretty sure that's exactly how you say it, was the XPrize Foundation, and so was Scaled Composites also played a role. Bert Rutan, these names are probably not as significant, although Sir Richard Branson was a founder of Virgin Group in the UK, and really became the first entrepreneur to take this new tech to a commercial application, and that he was kind of one who really tried to push this. So as far as invention evolution, initial development was just for a glider flight test with concurrent controls. You're able to control and propel it. Spaceship One configuration used the XPrize design to carry 3 passengers. That was their goal. Their next version, which is Spaceship Two, carries 6 passengers, and they're continuing to refine engines and subsystems or other systems to allow for longer suborbital flights, and of course to make it less expensive. So there is still very much a need for improvement in just in space flight and spaceship design and engine systems, propulsion systems. A lot of really cool, innovative stuff going on now that it's in the commercialized sector. Virgin Galactic again was the private human space flight. Their initial tests were in 2011 and 2012, so it was a long time after that the announcement of the prize. But the the first commercial flight, and this is just for human space flight. We're not just getting into suborbital, but again, that I think it was 1999 was when that prize was announced. 2004, I believe it was they won that prize, but they're continuing to push into space flight. They have a commercial flight planned, and depending on when this presentation is viewed, that would be a fun thing to Google and kind of see. It may be in the news here. They operate out of New Mexico. The shuttle replacement, so the retirement of the shuttle program in 2011 created a new need so that we no longer use space shuttles. Now we have to rely on private craft. We still get lifts from the Soyuz. Here's the Soyuz, and they sell seats aboard. The U.S. has to pay for to send people. They pay the Russians to fly them up there. I think it's something close to, it's like 50 to 70 million, at least in 2016. And people can just pay. If you have $50 million, go ahead and talk to the Russians about this, because they will gladly take your money to fly you up to space. Private people have done this before, just for if they have a lot of money to do that. So that's currently what we're paying, and it's just whatever to the highest bidder. The Russians really don't care. SpaceX is what we launched our Centaurus space little project on. It was on a SpaceX, and then it failed. It was actually the first fail for SpaceX, and it dropped in the ocean. And now it's launching again, or launched again on number 10, Dragon number 10. So we were on number 7. That did not work. Bigelow Aerospace is just a conceptual idea to make this hotel, this orbiting space hotel. That'd be pretty cool. Not a lot of space here. Get it? Space. They have some of these really cool design ideas, though, where there's these inflatables. So it doesn't actually take up a lot of space to fly it out there, a lot of room to fly it out there, but once you inflate it with compressed gas, then it's you have a lot of extra space here. But it is just a canvas type thing that is completely vacuum sealed, vacuum proof. So it gives you a lot of the space, but you don't, I mean, you got to make sure you don't have a lot of high impact on it, or you're going to go flying out into space. So in summary, over the next 20 years and beyond, there's going to be some amazing major changes as commercial organizations continue to work. So if this is a field you're interested in, there's a lot of really cool stuff that's going to be happening. A major goal is to reduce cost for access to space while improving safety and reliability. So reducing cost usually comes into play when you're talking about launching systems. How are you going to get it up into that orbital space, and being able to reuse spacecraft, and that's what SpaceX is really working on, and trying to re-land their spacecraft, because that's a huge cost. Then they just have to refuel it, retune it, but they have the main body still there. So this is kind of a similar situation to what the commercial airlines faced in 1930s, and that's sort of what was the boom to the improvement. From there, we are where we are now, where everybody flies everywhere, and so maybe that same thing will happen in another 50 years, where people are flying up to space regularly. If we have an improvement in costs, is really kind of the big thing. So there are a significant number of jobs in aerospace, and they're going to be provided by a lot of these commercial companies. That is it.